Okay, yeah, I think we're pretty much ready. So, hi everyone, welcome to Intro to Machine Learning with Python. A little bit of my background. My name is Zane. Um, I'm a software development researcher at the VT Bamboo Group. I'm also a CS student at Virginia Tech. And I'm just a hackathon enthusiast. I've gone to a lot of hackathons myself. Um, yeah, so first I just wanted to get some background on information on machine learning, just so you get a basic understanding of what it is. So what machine learning really boils down to is getting computers to behave in ways or do things without you having to explicitly program that. Um, yeah, and that's really just based off of certain rules that you create. And I'll be going over the specific models of machine learning that there are. Yeah, it's really just getting computers to do things without having to do things explicitly. It's being used in a ton of things that affect us in our daily life. More recently with stuff like self-driving cars, but even things in your home like speech recognition. On your computer, there's web searching, there's like spam filtering, and it's even used in things like the sciences. It's used in a lot in things like um, understanding Hubble telescope images and trying to understand things like the human genome. So it's used a lot in the sciences as well. So the first thing that I'm going to go over are the dependencies for the workshop. So I'll just be quickly going over how to install Python and a few other things. Let me just share my screen. Yeah, yeah. So really just the main thing is just installing Python. So just looking at Python, um, going to downloads, you can find the most recent installation right there, 3.8.3. And then you would just go through the installation for Python there. One quick note is, so when you install Python, I believe that there's a checkbox towards the bottom of the window that says add to path. Basically what that is if you're running something from the command prompt, you don't have to type out the entire address of where the file is located. You can just type out um, and then Python on your command prompt, you can just type in the file and then it'll just run. So it just makes things a lot simpler. So if you're installing it, I'd recommend checking the add to path box. And there's a few dependencies that I'm going to be going over in just a second. Yeah, well, actually, first I should be going over just how you work with those. So what you use to install packages is pip. So pip is just used to install Python packages. Um, you don't have to install it separately if you've already downloaded Python. It should just be with your copy. When you install Python, it should automatically install. So one way of checking if you have pip installed correctly is when you go to command prompt and you just type in pip. It's taking a second, but it should just give you all of the commands for that. And you can also check things like the version for pip. And then when you type in Python, it should also just give you the version for Python that you're using. Uh, just a second. Yeah. So just a few of the dependencies you'll have to install, which are um, one of the first is NumPy. So that's basically just used in a variety of Python applications for just calculation and running just doing mathematical calculations. So that's what it's used for. Matplotlib, which is used for bit graphing and plotting, basically. yeah, very quick, very lightweight. So that's what you'll need that for. Pandas is a machine learning module. It is used in a lot of data science, and I love working with data. And it has a few built-in machine learning models that you can use. Those are mainly for the first part of it, which is the linear regression. The next part of it is the natural language processing portion. For that, you're going to need NLTK, which is an NLP library that, again, has a lot of pre-built stuff in it, so you can just use the methods in there for when you're running your models. And then just some standard Python libraries that Python just comes with. Yeah, so just going to quickly show how you install a library. Okay. So that's just the basic formatting for how you install something on using pip. So requirement already satisfied. So I already have it installed, but you would just put a comma in between everything that you already, every type of library you're installing if you're installing multiple at a time. So yeah, that's just the way that you would install those libraries. All the code is going to be in a Google Colab book, and I'll be linked at the end of the workshop. I'll be linking in a text file to those Google Colab books, and then also just some general information on machine learning stuff. Yeah, so now we're just going to go into the few different types of models of machine learning. So the first one there is decision tree. Oh, just a sec. Yeah. So all decision tree really is it's one of the most simple types of machine learning models. Basically, it's just a lot of decisions that you're making about certain things in order to come to a conclusion. So on the left, you can see just a pretty basic type of that where um, you're basically using different circumstances to see what the weather is going to look like, just based on certain circumstances. It's very supervised, which we'll go to later what exactly that means. But yeah, this is a method of machine learning that's used a lot more than you would think, because people talk a lot about things like neural networks. But this is also used a lot in something I mentioned earlier, which was filtering images or removing noise from images on Hubble telescopes. This is something that's actually used a lot, especially as some kind of corporate development. Um, yeah, so that's a pretty basic type. Oh, just a sec. Oh, so some people are asking, how can I get pip? So if you're installing Python just online, Python already comes with pip. And then in your command prompt, just type pip, and then it'll just come up with that. So just to clarify, and that's how you can check that. Yeah, just a second. Oh, I just want to clarify. Is it showing the my screen right now? I just want to make sure because I wasn't exactly sure if it was. Okay, cool. So yeah, the next kind of very popular model I want to go over is linear regression. So this is really just um, graphing one dependent variable over how many independent variables you have, just to see the correlation between them. So it usually looks something like this, especially in the first coding example we're going to be going over. This is used a lot, especially with how simple it is in things like finance. Lots of stuff very data centric, especially to find trends in certain things that are very simple. Really, if you're trying to do something that isn't necessarily complicated, but it requires a lot of data, more so than any human would be able to analyze by hand, this is a great model to use if it's not too complicated. And then one kind of branch off of that is classification. So classification is used a lot in things like natural language processing and computer vision, basically just segmenting the different types of data into multiple types so you can kind of organize them that way. So just seeing the two different images, let's say that the blue dots are dogs, but then the green ones are cats. The line is basically trying to divide them. So it'll be able to kind of categorize those images um, into what they are. So that's kind of what classification is. Yeah, and just one thing I wanted to go over was supervised versus unsupervised models. Um, so these are two big parts of machine learning. So supervised is where you're really in control of the data, where you can see pretty much everything it's doing, where you know what the output can be, and there are, like in the decision tree example, there are clear rules set in place of how things are done, and then from that you can clearly see how the program came to an answer, and you can kind of adjust it from there. So whether it's a good one or bad one. And then from the data sample that you're giving the data, it's usually labeled. Um, yeah, it's usually labeled, and it's really just approximating relationships and doing mathematical analyses. And then unsupervised really, it's the more, I guess, complex of the two. Basically, where the output is unknown, where you don't know what it's going to be doing. And when it comes to a certain decision, you know you have an idea of how it got there, but you don't know exactly, because another part is you're not creating specific rules. And the reason for that is, like in the example I showed earlier with the dots, where I said the dog was blue dots and the cats are images are green dots. Imagine you have that scenario, but they're not labeled. So if you're just splitting them apart, but you don't know what either one would be. So this is really about trying to find hidden trends within data that humans aren't figuring out, and making new conclusions as opposed to just human conclusions, if that makes any sense. But yeah, it's really good for trying to uncover hidden structures within data. Yeah. And then the next part I wanted to go over was natural language processing. So this is what we're going to be doing in the second example of the workshop. So basically, natural language processing is a field of machine learning that deals with a lot of text and words. So it's really just giving computers the ability to understand and analyze text, where it can manipulate that text, it can read it, and it can also generate it. Again, this is used in things like search engines, like autocomplete, like spam filters, stuff like that. Um, and the specific type of natural language processing we're going to be doing is sentiment analysis, where you're basically seeing emotional trends within text. So in the example we're going to be doing, we're looking over a corpus of tweets, and we're going to be analyzing their emotional statistics and seeing if they're more kind of depressive tendencies versus angry tendencies. You can see a lot of things using sentiment analysis. And then, yeah. So the next part we're going to be going over is just the first coding example. Yeah, so before I get onto that part, I just want to leave a few minutes for any questions people might have, because that was a decent bit of information. So just before we move on, I just want to give some time for people to ask any questions they have. So how does a decision tree work again? Really, it's a very simple type of machine learning where you're just asking questions, and then leading that to certain conclusions that are predetermined. So basically, if you wanted, so basically, it's a very off the top of my head examples. Like if something is like the weather example, like if it's hot out, like you can say like, oh, is the temperature below 50 degrees? Is it above 60? Yes or no? And then it branches off into paths. And then you're like, oh, what is the humidity like? What is it sunny or is it cloudy? You can make certain webs of decisions like that, and then based on the answers, it can just come to a predetermined conclusion, and then it can just do that automatically. What was the last definition you showed us? I guess you could clarify what you mean by last definition. Could you list the libraries we'll need for this tutorial again? So again, I'll be giving you guys the Google Colab book, so you can view this code after the workshop is over, and I'll be up pretty much all night to help you guys. So like, I can help anybody through that. What we're really going to be needing is for the first part using linear regression, you'll pretty much need NumPy, Matplotlib, and Pandas, those three libraries. And then again, they're going to be listed in the after I put this out. And then for the natural language processing portion, you'll need NLTK, and then just like standard Python libraries that are already installed when you have Python. Yeah. So just put in your last couple questions before we move on to the first example. What does LR and NLP stand for? So LR stands for linear regression, which is just basically a kind of mathematical graphing model. And then NLP is natural language processing. So again, that's um, using machine learning to analyze text, basically. Are we not using the Keras package? I was considering doing something like that, but also just considering that a lot of people, maybe they never worked with machine learning, or they just really haven't gotten into that well. I just wanted to go over some of the fundamental information um, in this workshop, just so like people aren't overwhelmed or something, before going into like deep learning and that kind of stuff. Can you provide links for the packages / commands you're running? Yeah, that's going to be linked after the workshop is over. I'll just provide links to the Google Colab books. What is it supposed to look like after you install it? By it, I presume that you mean like the Python and the dependencies. Um, so I guess just one way to like check is if you go to your command prompt and just type in Python, then it should show like the Python shell and like it should tell you the version. Likewise, if you type in pip install whatever package, like just to make sure you have it, like it'll, well, one, you can check your files, but two, um, it'll just like say requirement satisfied, so you know you'll have installed if you type that. Was the recording for the workshop going to be posted? I believe these are going to be posted in the YouTube channel that DefHacks has. All right. If no one has any other like main kind of questions, I'll just be going into the first example. All right, so this is the first example we're going to be going over. Essentially what this is doing is it's trying to, and it's a basic example of, say that you're given the the years of experience of a person. We're trying to determine around how much should their salary be. So this isn't a super accurate example just because in real life there's a whole bunch of different factors on that. But this is just a basic example just to get you guys to understand like what it should look like, and I guess just how linear regression works, because it's used a lot in jobs and stuff, especially for stuff like finance um, and stuff like that. So really just the first portion of this code is just importing the packages we talked about. If you haven't used Python before, just for clarification, this as part just it just means when you're using it later on in your code, um, you don't have to specify numpy dot whatever. You can just use np. So this is just like a name thing to condense your code a bit. Yeah, and then the next part is the is importing the data set and splitting the values into the x and y. So this CSV file, if you want, I'll probably also link to this in the resources I'm going to be posting after the workshop, just so you guys have everything. So yeah, you just create a variable and set it equal to the values from that data set, and then you're setting the x and y to the x and y components of that data set. And then this part we're using sklearn for the train test split. So basically what this is for, so when you have a data set and you're trying to train it on your model and then run it on test data to see if it works, when you're doing that, you don't want to need like two different data sets. So what you can do is you can just take one larger data set and just use sklearn to split into two, just so that you can train it on one and then run it on the other one to see how it works. And then for the linear regression, sklearn and stuff like that has a lot of built-in functions for things like linear regression. So you don't have to like hard code this stuff, which is great for you guys in a hackathon settings where you're on like a time restraint. You don't need to code all the stuff from scratch. There's tools out there and libraries that you can use to do that. So you just import it from linear regression from sklearn, and then you fit it to the split data set from before.
Okay, now you can see it is displaying that.
Okay, I think there's someone talking. And yeah, this is just and this is just the predictor. Again, from the test train split that we were going over before. We predict the y-axis for that, and then just to print out the results and make it easy to understand, we just use matplotlib to use a scatter plot. Scatter plot is what you would usually use for linear regression. model. And this really just does stuff like change the labels when you're displaying it, change how it plots, the color, stuff like that. Yeah, and then just seeing it right here, again, this isn't super accurate to what it would actually be, but just to understand how linear regression functions, it's a very good example just to show how simple it can be. Because really, this isn't that much code. Again, it's simple, but it's a good way of understanding it. So we can really just see the line of best fit and how all the data points relate to one another. So yeah, this is why stuff like pandas and sklearn is really useful. If you were trying to get into machine learning and you're wondering what libraries are really good to try and learn from, those are two pretty big ones that I would recommend getting into. They're very useful. All right, so before we move on to the second example, I'm just going to give it time for a few questions. Let me just go back to the screen. Yeah, just whatever questions you guys has before I move on to the next part. So yeah, this is not Python. This is a Google Colab book. This is just so I can like show you guys the code, and basically like I'm just going to be providing like a text file with this. So it's just like a link you can go to. If you use Jupyter notebooks, it's kind of like that. Yeah, so Google Colabs are very good, especially for like showing off code. Yeah, so you don't need to install the dependencies onto your computer unless you're using actual Python, which you would normally, just like to show it I'm using this. So yeah, here I don't have to install it, but yeah, you would need to if you're just using Python. Yeah, I'll just give a couple more minutes for any questions about this before I move on to the second example. Can you explain again why you split the data set? Yeah, so basically, like I said, when you're training your model and then running it to see if it works, like you don't want to like do, because if you train on one data set, it's just working off of that data. So of course it'll work, but then if you're running off of different data, that's really the teller for like if it actually works or not. Because that's what you're trying to do is you're trying to use new information with it, so you can make decisions. So that's just splitting it is just one way you do that, so that you don't need two data sets. You can just take the same data set and just split it in half. Why do you pass x underscore sets as the argument on the line y under prediction regressive predict? Oh, so that's really just because um so like these names like they might look a little confusing, but really it's just about the x and the y. So like you're trying to predict the x based on the y based on the x. So if you did like y underscore using y underscore test, like it would just be doing it off of this, which is not what you want. You're trying to predict salary based on use of experience. This is really just about like where the variables are located. Like that's why you do it that way. So yeah, hopefully that clarifies that. What does regressor mean? Regressor is just the naming um, I used for just the linear regression method. The linear regression is just the variable name I said. Just the linear regression method is just something from sklearn. It's like a built-in function that you can just use, so you don't have to build it from scratch. The greens are just comments. Yeah, the green signs are just comments. Yeah, if you haven't used Python, to write a comment, you just use the pound symbol, and then if you wanted to write like, just so you guys know, if you wanted to write a multi-line comment, you can just do 3 quotation marks. Yeah, so it's really just that if you want to do a multi-line comment. What is random underscore state when you're splitting data? Oh, all that does is just randomizes the data because you don't want it to be like in the same position all the time, right? So it really just randomizes the data when you split it. So they're not all in the same position. They're like randomly strewn about. Yeah, it just shuffles it basically. What does regression mean? So linear regression, it's more of a math thing. So if you know it from math, like it's really just that. It's just a type of statistical graphing that you use. And then in machine learning, we just produce that as the output. Yeah, it's a type of graphing. And then what models should I learn for machine learning in Python other than sklearn? So there's a lot of useful ones, and it also just depends on what you're doing. So like, excuse me, if you want to do something like computer vision and natural language processing, there's like specific libraries for those that are specifically built for them. But then like, as the general ones are like pandas, and then even stuff like NumPy is used everywhere. It's like, and matplotlib as well. So those are good just general ones. But yeah, like stuff like pandas that is also just good for data science. But yeah, the stuff, if you're doing like computer vision, there's like OpenCV, which is a good one. If you're doing natural language processing, NLTK, Beautiful Soup, those are some great ones. So yeah, it also just depends on what you want to do. Yeah. If you have any last minute questions, I'll answer them quick, and then I'll just move on to the second part. All right. Yeah, then I'll just move on to the second part, I guess. Just answer one last question. Can the salaries be predicted outside the range of the experience given in the model? They definitely can. It's just that like the data set I used was just very limited, just because this is strictly for like demonstrative purposes. But yeah, if you wanted to, you can do it out. It just scales, so you can do it outside the range of experience that you're doing. Yeah, it's just that the data set I'm using is just really small, just because that doesn't need to be huge. Yeah, so just go over this next part. This is basically we're analyzing tweets and we're using sentiment analysis to basically see emotional patterns within those tweets. And then from there we can make certain conclusions. So one like hackathon project I've seen a lot is like if someone, because of like everyone's depressed nowadays, but like you can see depression tendencies within text, and you can see like, oh, like in this community there's a lot of depression tendencies and stuff, so you can kind of do things and make data visualizations based off of that. So that's a cool application of it. But yeah, the first part of this is just importing all the stuff from NLTK. I just use download all just because like this is just a Google Colab book. But yeah, you can just download the specific ones from there in the comments. But yeah, just to go over it. So just word net limitizer. So basically, what limmatization is. So let's say you have 3 words or like a bunch of words with the same base word. So like run, like there's also running and ran. Like those are all essentially the same word, just in different like tenses and stuff. or different inflections. So lemmatization is just breaking them down to the stem and just making sure they're treated as the same. So it's not like you have a bunch of different words. It just simplifies it so they'll treat it as the same thing. And then NLT.corpus, you're just importing the Twitter samples. This is another good thing about NLTK and some other libraries is if you need sample data, they actually do have like built-in stuff for that. So Twitter underscore samples, they have a whole corpus of like Twitter samples that you can use and stop words. So this is used in natural language processing all the time. So like it's really just words that you and punctuation that you don't need, like periods, commas, spaces, exclamation points, stuff like that. Like types of punctuations that it just garbles up the text if you were trying to read it. So you basically just stop those. So and you clean the text basically. So that it's just like all like just the most important words and stuff that you're going over, and not like periods and stuff. So import POS tag. POS just refers to part of speech. So yeah, that just helps with like analyzing emotional patterns, is like verbs, nouns, whatever. So it just tags those. And then tokenization, that just basically converts words into individual tokens that you can manipulate individually. So yeah, it's really just breaking sentence garbled text into just like individual words and stuff. Frequent distribution, classify, like I mentioned before with the slide, is just classifying different types of words into different categories. Frequent distribution, it's just, this is what I use to like see like how much of a certain word is there in the text, like how many times does the word maybe appear in there, and stuff like that. And then naive Bayes classifier. So naive Bayes is a type of mathematical analysis tool. So this is a type of machine learning which it's unsupervised, so you don't have to directly tell it. So that's one good thing, is if you want to do something like a neural network or deep learning, you don't need to do all that from scratch. There's stuff like this which has stuff built in which you can use for a hackathon. Yeah. So the first part of this, and I'll go over this stuff with this in a second because this looks wonk. But the first part of this is just removing the noise, like I mentioned before. It's like from the tweet tokens and the stop words, basically just removing the noise, and then putting those into a list, just so you're having clean text. And then basically this part is just a regex, which is basically, this is a standard thing that you could just like copy paste and use. It's really just a method of deciphering URLs. So you can tell that it's a URL for one, but also if you need, like say your project is dependent on like, if it has like an HTTP protocol, like if it needs that and it can't be HTTPS, like you can also tell that. So yeah, this is just a regex just to determine URLs and stuff. Yeah, this is just the POS tagging. So basically just organizing them into different parts of speech, like noun, verb, adjective, stuff like that. And then lemmatization, like I said, lemmatization, if something has the same base word, you can basically just make it so they're all treated as the same word and not just taking up unnecessary computing space. So that's what lemmatization is. And this part is cleaning the tokens of the actual stop word. So stuff like a punctuation and stuff. So again, it's a second cleaning of it, just to make sure it's just clean text all the way through. And this is getting the tweets from the model using the cleans token list as the input. And then the main part of it, which is this, is so just to clarify this, so if underscore name equals main, so this is what's used if so say you have a larger system, right? And then you're not just running this from the file, you're importing this into your other program, or into your other script. This basically means, so if this is run, like it only runs if you just run the script directly, not if you just import it. So this is very good just in general with Python, if you just want to control what's being run at what times. Especially if you're only doing some stuff for testing and stuff, it's very good. Especially for a hackathon where not everything is super organized and stuff. So really just, I have, there's positive and negative tweets .json. So again, that's just from the corpus from NLTK. So that's like built in when you install it. You have access to those. And Twitter.sample strings. This is just an example string I used. It could be really anything. This is just for example. And you're just setting the stop words to just like the English stop words. And then you're tokenizing what's inside of those JSON files. And then creating the lists for the clean positive and negative tokens. And then what just all you're doing is you're just appending, which basically just adding to the list of positive and negative tokens, clean tokens, is just removing the noise from there, stuff like stop words. And then frequent distribution, you're just distributing the positive and negatives, and seeing the quantities of those. And then yeah, so print most common. And then this part, so you're just splitting, you just have two data sets. So tweet underscore dict, and then just positive and negative. So yeah, again, a lot of the stuff is just built into NLTK. So again, you don't need to do all this from scratch. These are built, some of these are built-in functions. And then the next like main part is setting up the data set. So kind of like what we did before, we just take the data set and then we merge them together, and then we shuffle the data set. So because we don't want just like all positive then all negative, we want them to be shuffled and evenly distributed. And then you just do a test train split on the data set, so that one half is what you're training on and then the other part is what you're testing on. And then again, we're using the naive Bayes classifier to train the data on the specific JSON that we have. And then for actually printing out what we have, so we're printing out the sentiment of it, and I'll actually just show you. This is just because I did all. Yeah. So this is really just the actual data that you're looking for. Yeah. So the first part of this is the accuracy. The accuracy is because not all of this is super accurate. This is actually a very good accuracy score, but that's only because this is a very limited data set and like this very limited situation. But once you go to a higher level, like your accuracy gets less and less because it's not always super accurate. But yeah, it just shows the accuracy of your sentiment analysis. And then this is all just the data and the ratios of positive to negativity within the different parts of the positive and negative tweets that you're analyzing. And then the last part is the frequency distribution. So I just use this as an example just to show how it works. So it's just like not balanced. But if you have like stuff like a whole book or like a whole web page that you've scraped, it'll be a lot more. There'll be a lot more buns. But yeah, I just use the frequency of distribution with how these words are distributed throughout the text, what appears the most. All right, so now I'm going to answer some questions. So I think there's also a workshop after this one, I think with React or something. But I'm going to stick around for a bit longer just to answer questions about machine learning for one, but also just if you guys have questions about hackathons, because I've been to like too many hackathons. So if you guys have questions just about presenting and that kind of stuff, I'll be able to answer those. So yeah, you can stick around for that, but that is the bulk of the workshop. The rest of the part I'll really just be answering questions like that. What does LTK mean? It just means Natural Language Toolkit. That's just the acronym for that. Okay, cool. The React workshop is at 10. Can you, let me see. So, can you show how an example tweet could be passed through the model to see its predictions? So really all I did just to like, because there's a whole corpus of these tweets, but just to show like, if I know what the sentence is, I just did it in the print statement. So I just create a variable called custom tweet, and then I removed the noise and then tokenized that sentence, and then I printed it after the positive and negative analysis was done on it. So you really would just do that in the print statement, and then just run your methods on that. This document will be provided for us, right? Yeah, I'm going to be providing both books after the workshop is done. Is there a way to import all libraries from NLTK at once, or do you have to type in from NLTK and import specific ones? So, so yeah, I mean, you wouldn't just add all of them. So like, if you only need specific ones, you like the whole from the whole package of NLTK STEM WordNet, like there's a whole bunch of things in there, but you don't need all of them. So you just use the ones you need. Otherwise, like it would just add like a whole ton of stuff. So like if you see like all of this text right here, like I just use NLTK.all just because like I can, because it's just a Google collab. But again, you can just use like these specific ones, especially if you want to cut down on runtime, because if you just did it all like that, it would just be really slow. So that's the main reason for that. Thanks for this workshop. Well, thank you. How would you recommend someone who's relatively new to Python to start machine learning? What do you do to start learning? Yeah, so this is a question I've been getting a lot. With the whole coronavirus situation, one thing to take note of that wasn't as available before are courses. So a lot of like stuff on Coursera, but also stuff from actual like legit universities are now free. So just take note of that and do a little bit of research on that, because there's some courses out there that are now free. I don't think it's specific to machine learning, but there's like a course in Stanford, and there's courses from like a whole bunch of other universities that are now free. So one in particular, so one in particular is the Stanford machine learning course. I would highly recommend this, not only for your personal development, because this is a very just standard, like popular machine learning course from Stanford. So it's like, it's legit when you talk about it, but also let's say I'm a hiring, like a recruiter for a company. I may or may not have taken this course, but if I see that you've taken this, like I can infer a few things about your level of experience without even having to go through the whole spiel with you. So if I have taken it, I'm like, okay, I've taken this. I know what the material is. So I know they're at least at this level. So they're probably a good fit. And even if they haven't, like they just would probably know of the course, but also it's from Stanford, and from NJUNG, which is a great professor. So yeah, just that kind of, I guess, publicity that it has, besides just from being a great machine learning course, is just that it's offered like that, and it's very good to just kind of break the ice, especially when you're getting hired. Recruiters can take note. I've noticed a few times, like they've seen this on my resume, and is one of my courses, and we start talking about it. It initiates a conversation. So that's one thing I think that's very good for. There's a whole bunch of other Coursera courses, but this is a particularly good one, I think. What databases could you use to get data to train to recognize video similarities, other databases for pictures? Um, so I believe that there are. If you were looking into specific libraries, I believe stuff like how NLTK has a corpus of like tweets and stuff stuff like OpenCV and like libraries specifically for computer vision. They often have like dedicated corpuses full of like sample photos, sample videos, and stuff like that. And there's just ones online. So yeah, there's actually a lot you can look into with that. There's definitely a lot out there, especially ones that are just built in with certain libraries. All right. So so just one thing I'm going to quickly go over is just a sec. Yeah. So just one thing I'm going to be going over. And this isn't exactly related to machine learning, but I think it's very helpful. Um, just for you as people going to hackathons. Um, I I also do a workshop just at a lot of other places about hackathon tips. I just wanted to raise a few points about what you can do to make a great hackathon presentation, just so you guys can have that awareness. Um, so yeah, just one quick thing is, so with your presentations, because understand I'm also a judge, right? So I'm going to be viewing your projects, so this is probably good information. So I believe that your projects are like 2 minutes long or something like that, which is pretty standard for most MLH hackathons. So one thing that you really want to do is just make the most of that time. If I can say anything, it would be that. Just because I see some people, they take too much time speaking, but they don't show enough of the app. Basically, that whole 2 minutes should be basically just all your app. Really, one example is there's a lot of ways you can do it. You can just show your app in the background, it working, and then you can talk about what it's doing, like an overlay. So yeah, just making sure that you're really just showing off as many features of your app or your project as possible. Just everything that it can do within that 2 minutes, because it really is a short amount of time. Um, I've seen some people that have like slides and stuff. I wouldn't really recommend slides. You can if you want to, but I feel like those are more useful in a in-person hackathon. When it's not in person, like you have a limited opportunity to show off what you can do. Really, what you have is your video, which is the like biggest part, and then you have your code, like your actual GitHub or whatever, which is the second biggest part, so that we can actually see how it works. And then the third part is the DevHacks page, which is like it has some impact, but most of it should be in your video. So yeah, just making sure that you're really just talking and enunciating properly, that you're confident while you talk, but also not putting too much fluff or anything, because this is a very limited amount of time for you. So yeah, just making sure you're packing as much information as possible and showing off as much as possible. And just like some general things. So this is I think it's a 36-hour hackathon. I think so. Like I personally and most of the other people who are judging, we don't expect a super complete solution. But we do expect a certain level of polish for your idea. So if your hack doesn't have like, it doesn't tick every single box, as long as what what it's trying to do, it does it well. Um, this is a pretty good like thing. Like if it doesn't have the best UI, that's not a huge thing, unless it's imperative to your project. So one thing I personally do when I'm judging is like I see what is this project trying to do. So if this project is trying to cater to the elderly, for example, and it has like a more complex kind of UI and it's not super intuitive, like I would kind of like dock points in my mind for that, just because if it's specifically for that um, audience, then it needs to cater to that audience. Whereas if it's not as much for that, like it's more acceptable for it to be that way, as long as it does what it wants to do very well. So that's just one thing there. Yeah, and then another part is just creativity. Just think outside the box. Um, yeah, just like because there's a lot of things, especially with the coronavirus and all the things that are happening right now. You kind of see a lot of the same stuff, which isn't like necessarily a bad thing. But also, if you're just having a unique idea, that puts you like way above like a lot of other places, a lot of other hacks. Um, so that's another thing. Is just make sure you're innovating as much as possible, and that you're not impacted by like I guess preconceived things of what you should do. Just do whatever you want, really, and just to be free with it during these 36 hours for the hackathon. Yeah. Just two last points I wanted to go over. So when we're going over projects, I'm going to just one last point about that. I'm going to be going over everything like UI, like how technical is this, how creative is this, and then also how does this actually solve what they're trying to do? Because far too often I see some people trying to create something that tackles an issue, but it doesn't necessarily do it well, or there's certain business things or scalability things that it doesn't think about. So as a kind of also business-minded person as well as a ML developer, I have to think about those things. So seeing that a hack goes over those kinds of things, it really just shows how much thought they put into this. So in my mind, that makes it seem of a lot higher quality. Um, so yeah, that's another point there. Um, just to answer a quick comment in chat. Would you recommend focusing on the technical side, or would you say we should spend time talking about the problem impact business side of it? So my answer now is different from how it would be in an in-person hackathon. In an in-person hackathon, I would recommend you say a little bit about that. It's still the same for like if you have a video. I would really just have like a quick like introduction, like a very quick like sentence or two, just about what your problem is, and why you're solving it. Just because a well-defined problem just sets the tone for the rest of the video. Um, Yeah, I would go more in depth with it if there was an in-person hackathon, but you don't have a lot of time. It's just like 2 minutes. So I would really focus more on the actual app or project. But yeah, just a sentence or two about that. It goes a long way. Um, would you recommend focusing on the technical side? Um, so if your app does a lot of like, if it's built on a huge algorithm or a huge neural network, then if it doesn't have the greatest UI, but it doesn't really need to, like I would still take note of that, but I wouldn't be as critical of it because it doesn't necessarily need it. But then if something is UI based, or like it really needs a good UI because it's trying to be a simple, um, easy to use solution, and it's not super technically appealing, it would be okay if it's not super technical, as long as what it wants to do is be a accessible, simple interface. That's what I would judge more. So it really just depends on what your project is trying to do. All right. I'll be sticking around a bit longer. So if you guys just have general questions or questions about ML, you can continue to ask those in chat. But yeah, that's really the bulk of what I wanted to talk about. So really, it's just gonna be answering the last couple of questions. Oh, what are the if statements for showing the token cleaning method? I can show it just quick. But again, like I'll be providing this whole like notebook or both notebooks after the workshop is done, so you can look at it like as much as you want. Then I'll be providing it after. But yeah, if you're referring to like referring to the if statements, if you're referring to like this stuff right here, I assume that's what you're talking about. This is just like using POS tagging, so part of speech. This is really just tagging things if they're nouns, verbs, adjectives, um, stuff like that. And then, like I said, lemmatization. Make sure everything's treated as the same root word. And yeah, and then again, just taking the tokens that you have, and then just cleaning it of things like punctuation and yeah, just other stop words that you have, so like exclamation points, commas, stuff like that. Just cleaning of those so that the tokens are now clean of all of those things. So it's just text. It's just pure text. But yeah, I'll just stay on for a few more minutes, just in case anyone has any other questions. Also, I think they posted in chat or something that they're trying to make like DefHacks like hoodies and stuff. I think they have like a Google form for that if you guys wanted them. I would highly suggest you get one just because like for an online hackathon, well, one, you're supporting like a good organization, but two, like just like merchandise specifically of that hackathon, like nowadays you're not going to be getting as many of those because everything's really virtual and it's hard to like ship all that out sometimes. So I would really recommend you because I think I might look into getting that just because like it seems really cool. Um, yeah, I think that's in like the general channel or something. But yeah, I would look into just like filling out the Google form for that. Yeah. So if you guys have any last questions, just get them in right now. Otherwise, in a minute, I'll just end everything off pretty much. Will you be available for help tomorrow as well? Yeah, I will actually be available for help tomorrow, and also like I don't know how many other mentors are doing it, just because like it's a lot, but I'll also be awake most of the night. So like while if you guys are like working overnight on your hack, like I'll be able to like help you guys. Just because like I'm used to staying up all night at hackathons, so like it's really helpful if like someone's there to like help you during that time when it's like 3 in the morning and nothing's working. um, can you send them the link for the notebooks? Yep. I'll be putting them in the workshop channel after the hackathon and some other resources just on like machine learning stuff. All right. So I think that was pretty much all the questions everybody had. So thank you guys so much for attending this workshop. Like I said, I'm going to be available all through the night and then tomorrow if you guys need help. And then I'll also be judging projects. So it'll be really great to see your products. I hope I see a lot of cool stuff. So yeah, thank you everybody for coming and good luck.